see on that calendar, we've got 5.5 geometric mean to cover today. Then we're going to do a review game called Grudge Ball tomorrow. I think y'all will like that. It should be fun. Then we are quizzing Thursday. You'll have a work day Friday where you can choose whether you work on quiz corrections, your review, your extra credit, or if you're behind on Delta Math, or not Delta Math, but our practice assignments, whether they're Alex or Delta Math or whatever, you can do that. And then we'll have a day to go over review questions Monday, and then your test is a week from today. So your review is due a week from today. Your extra credit is due 7:20 a.m. a week from today. Okay, everybody understand deadlines, what's coming up? Okay. All right, so let's take a look at geometric mean. Oh, it won't let me close this. Okay, so geometric mean uses the altitude of our triangle. Okay, so if you have an altitude, there's two rules that we're going to look at. Okay, when you have an altitude of your triangle drawn here, okay, and you may notice these are all in right triangles. Okay, when you draw the altitude from the right angle, C is the right angle of triangle ABC, yeah? Okay, so when I draw the altitude from vertex C to the hypotenuse, okay, I create another right angle. That's what an altitude does. It connects the vertex to the opposite side at a 90-degree angle. Okay, so when that happens, it splits that hypotenuse side, that AB, okay, we're going to call it X and Y for those two lengths. Okay, and then we're going to call the altitude H, because altitude is just another word for height, right? Okay, so, and then we will call the side length the leg by the opposite angles vertex. So vertex A, across from it is leg A. Vertex B, across from it is leg B. And notice the vertices are capital letters, the lengths are lowercase letters. Is everybody good with how things are labeled here? Okay, so the altitude rule says that that height, that altitude squared, is equal to the product of X and Y. Okay, so those segments that this hypotenuse is split into, if you are to multiply them, you get the height squared. Okay, so this is a rule that we can use to find that height or to find these missing pieces, depending on what's given to us. Okay, gentlemen, I need your conversation up there to stop. Thank you. Okay, now there's another option, okay, another rule called the leg rule. Okay, so in the leg rule, you can see there's two versions because one uses leg A and one uses leg B. Okay, because there's two legs in a right triangle. Okay, so whichever leg you're using, okay, so we'll start with A. This is the longer leg here. Okay, the length of that leg squared is going to be equal to the product of that portion of the hypotenuse, that side's portion where the altitude split it, so Y, times the hypotenuse length, C. Okay, and then if we use leg B, then we would need to change the Y to the X, because X is that side's portion of the hypotenuse. So X times C would be B squared. Okay, so this is what we're doing. This is how we're going to find missing lengths. Depending on what's labeled, will determine if we're going to use the altitude rule or the leg rule. Okay, and what's being asked for. Okay, so we have those up there as reference. Okay, altitude rule, leg rules. Okay, so in number 1 here, we are given those two portions of Y and X. This hypotenuse is split by the altitude into 9 and 4. They're asking us for the height, okay, for H. Okay, so in this one, should I use the altitude rule or the leg rule? Yeah, I don't know either of those legs or the height. Okay, I have to know like some more information if I was going to use the leg rule. Okay, so here I'm going to use altitude rule. So I'm going to take and label, if it's helpful to you to label, it doesn't matter which you label A and B or X and Y. If you like to always do the long one is A and the short leg is B, and then the Y with the A and the X with the B, so that it matches our formulas, you can do that if it's helpful to you. Okay, I'm not saying you have to label it this way. Okay, but the altitude rule says that H squared is X times Y. So our X squared will be 9 times 4 or 4 times 9, which is what? Okay, and how would I get the square, H squared? How do I get rid of that square? What's square root? Okay, the opposite of square is square root. So what you do to one side, you do to the other. Now, I don't want you to forget in algebra, when you take the square root, when we're solving for actual roots, those are x-intercepts, we always do plus or minus when we take a square root, because it could be a positive, it could be a negative. Because wouldn't both 6 squared be 36 and also negative 6 squared be 36? Yes, so typically when you're taking the square root, you always want to put a plus or minus in front. But in the context of what we are using it for, we're finding the height of a triangle. Would it make sense for the height of our triangle to be negative? No. So in these problems, when we're doing geometric mean, when we take the square root, we do not have to do the plus minus. Okay, it's just going to be the positive 6. Make sense? Okay. All right. So in number 3, I'm going to go across here instead of down. So in number 3 here, do you think I should use the altitude rule or the leg rule? Yeah, it's a leg that I'm looking for this time. Okay, so this leg rule, and if you want to relabel these so that that's not an X, you're welcome to. You don't have to. You can use whatever letters you want to represent this stuff. But if you want to label that as like your B and your A and your Y and your X, you can do it that way. Okay. Now I need C for the leg rule. So what is the total length of C? Okay. So for the leg rule, I'll color code. When I use altitude rule, I'll do it in red. I'm doing leg rule here, and I'm looking for B. So B squared is X times B. So my B squared is 4 times 25, which is 100. And I would take the square root, which is 10. Okay, so I renamed it B. They called it X. It doesn't really matter what you call it. That length is 10. This makes sense so far?
Can we get the formulas on the?
I will think about it. I'll let you know, John.
Can't use the altitude rule.
Why what?
Why can't you use the altitude rule?
On this one, the altitude rule, you would have to know the height unless you're looking for the height. And I don't know that height, that altitude. Okay. So it kind of depends if you're given the height versus a leg, or if you're looking for the height versus a leg. So yes, if you wanted to find the height first using the altitude rule, because you know X and Y, you could find the height first, and then you would have the height and 4, and then you could do Pythagorean theorem. That would work, yes, but that would be extra steps. But it would get you the same answer. So if you can only remember that one rule, or that's the only one you understand, you can do it that way. Because once you have the height, then you could find A or B doing Pythagorean theorem of these smaller right triangles created, couldn't you? Yeah. That's if you remember Pythagorean theorem as well. All right, let's look at number 2. Number 2, I'm looking for a leg. So ideally, it would be easier to use a leg rule. Okay, and again, if you prefer to keep everything always labeled the same, you can relabel that, but you don't have to. Okay, know that whatever the leg you're looking for squared is going to be equal to that portion of the hypotenuse times the hypotenuse. Okay. So then I take the square root. So essentially this geometric mean, whether it's the leg rule or the altitude rule, is like a shortcut to what you were kind of talking through, John. All right, so in number 4, this one's looking for the altitude. So the altitude squared is equal to the product of the two portions, right? So 12 times 8. Okay, so 12 times 8 is 96. Oof, we finally don't have a perfect square. When I try to take the square root of 96, that is not a perfect square, is it? So I'm going to need to remind myself how to reduce a radical. I don't remember what unit we did this in earlier this year, but y'all remember doing our factor trees? What are some factors of 96? Any two numbers that multiply to 96? 3 and 32? Okay, 3 is prime. 32 I can keep breaking down. What are some factors of 32? 4 could break down to 2 times 2. 8 could break down to 2 times 4, and then 4 breaks down to 2 times 2 again, right? So remember, when you complete your factor tree, you get it all down to where all the ends are prime numbers, because this is square root, squares 2. We're looking for 2 of a kind. We're looking for pairs. So there is a pair of 2's. There is a pair of 2's. So 2 different 2's, because it's from 2 different pairs, get to come outside the radical. Okay, and then these others that don't have a pair, that 3 and that 2, have to stay inside. Okay, so then I simplify this. What is 2 times 2?
4.
And 3 times 2?
6.
So 4 root 6 is the reduced radical or simplified radical for square root of 96. You could check that in Desmos, even scientific Desmos. If you typed in square root of 96 and 4 square root of 6, you should get the same decimal. So that should confirm that you reduced it or simplified it correctly. Okay. All right, what about in number 5? I'm looking for both legs. Okay, so I'm going to have to do the leg rule twice. Okay, so for X, I'm going to use the 4. And what's the C? What's that total length? 10. The hypotenuse of the big triangle is 10. Okay, so I would write this out as x squared equals 4 times 10. Is 40 a perfect square? Okay, I'm going to have to do a tree. Okay, what are some factors of 40?
4 and 8.
Okay, I heard 4 and 10 first, but yes, you could use others. Okay, now they're all prime. So I've got a pair. Now notice, I want to remind you, the pair does not have to be next to each other like I happened to circle up here, how the 2's came off of the 4 together. Okay, you could get them from different branches like this. That doesn't matter as long as there's a pair, as long as there's 2 of them. So a 2 gets to come out, and then this 2 and this 5 have to stay underneath. So what does that simplify to? Yeah, 2 root 10. So x is 2 root 10, or 2 square root of 10. Okay, and now let me do a different color. For y, I'm going to use the 6. So y squared would be 6 times 10. Is 60 a perfect square? Nope. So I'm going to have to do a factor tree here as well. What are some factors of 60? Yeah, I could go back to that 6 and 10. 3 could break down, or 6 could break down to 3 and 2. 10 could break down to 5 and 2. Notice, I can get a pair of 2's even though they're not next to each other. That's still a pair of 2's. So a 2 comes out. The 3 and the 5 have to stay underneath. So that is 2 root 15. All right, last but not least, this time I'm going to have to work backward because it's not a leg or an altitude I'm looking for. It's the C value, right? The hypotenuse. But which formula, the altitude rule or the leg rule, uses that hypotenuse? The leg rule, right? And because we have one of these legs, we have that 4. So remember, it's the leg squared equals that portion of the hypotenuse times the hypotenuse. So I just have, this one's just working backward. Okay, so 4 squared is 16. Then get rid of the 2 by dividing. So that hypotenuse is 8. Y'all feel okay about geometric mean? Okay, I'm going to stop this recording here and go activate your practice. And say that again. I had to look at what I was looking for C, right? The hypotenuse. Okay, and I know a leg. I don't know the height. So looking at my 2 options, the C is used in the leg rule, and I happen to know one of the legs. So that's, I had to use that one. I the altitude, I would have, to work backward, I would have either needed to know the H, the altitude, or this other side. I could have found the altitude, but if I knew that other side, I would have known C. So that wouldn't have really happened anyway. So you just have to kind of look at what you're given and what you're asked for to determine, should I use altitude versus leg rule? All right, so I'm going to stop this recording, activate y'all's practice, and then I will also go over questions. I know some people had questions on the 5.3 or the 5.4 Alex assignments. I can go over some of those questions with you.